and welcome to College World. We are back to our C4 tutorials. If you watched the first video, it was the first multiple videos. They were about our first chapter in C4, which was partial fractions. We explained everything in it, and then we solved questions and provided you with tips and tricks. And then that we are done with that, as we said, we're going to be moving with the syllabus. So naturally, our second chapter for discussion today is going to be Chapter 2. Chapter 2 is titled Coordinate Geometry in the XY plane. So what is coordinate geometry and what do we need to know in order to solve questions that come about coordinate geometry? We're going to cover objectives just like we did in the past videos regarding this chapter in order to cover up all the aspects that can come. So we're going to cover 4 objectives today, and the first one is going to be a bit different than the past chapter because our first objective is to cover up the background information. Why is that? It's because this chapter is definitely one of the easiest chapters you'll face. It is very basic. It's all just about like equations, line equations and such. It's very easy to tackle. However, the difficult part is to remember all the background information you need in order to actually solve them. So that will be our first part. The second part we're going to cover is going to be definitions, just like the past chapter, but this time the definitions are less and they're easier and to the point, so this section will take no time. So that will help us move on to the third section, which is the most important to you, which is the questions section. Since the questions are not actually diverse like in chapter 1, this time we're not going to go by types of question, but we're going to give you 3 different examples from past papers that cover up different aspects of this chapter. And then for the fourth part, which is our usual tips and tricks, we're going to try and provide you with some tips in order to be able to solve such questions or anything that has to do with this chapter. So let us move on to cover our first part, which is our background information. So background information. What do you need to know in order to solve questions that come in this chapter? What do you need to review before solving? Well, here are the things you're going to review, and we are gonna actually take some time to review them with you in order to make sure you understand them correctly. Well, so first of all, you know what a line is, different equations of lines, and you technically know everything that has to do with them. We are going to first start by the basics of any equation, which are the domain and range. So what is a domain and what's a range? Technically, the domain is just a list of numbers that you can apply the equation to. It is your how much numbers your independent variable can be, and the range will be the dependent variable, so it's the highest and lowest numbers that appear in as a result of this domain. So here, let us say we have the equation, let's say we have this drawing, your x-axis, you have your y-axis, and then your graph is a parabola which is shaped like this, and this is of course your 0, 0, and one of your points is 4, 4, and then your other point is 9, 6. So 6, 9, 4, 4, and this is 0, 0. Technically speaking, the equation of this line as a parabola is y equals to x squared prone to some coefficients, and in this case your coefficients are gonna actually be 1 over 4. So here you have x squared over 4. Yes, that's it. So this is your equation. What is your domain and what's your range? To check your domain quickly, what we do is that we look at the numerator. If you don't know what your numerators and denominators are, go back to our last video. The numerator is the number at the top and the denominator is the one at the bottom. For your numerator, what you need to check is that if you have a radical, you need to make sure it's positive. So in this case, it's actually squared. So whatever happened, there's no radical. So you don't mind the numerator. For the denominator, you need to make sure that it's never equal to 0. For example, so you know what I mean, for 1 over x, your domain will exclude 0. And here, if you have x minus 2, your domain is going to exclude anything that is less than 2. So your domain is going to be x is greater than 2 because it cannot be negative. It's actually greater than or equal because it cannot be negative. So this is how you check for your domain. For your range, you simply just check. You can graph it and check how would the range. To get the range, you can actually graph your equation now within this domain and see. So for x minus 2, you know that x is like this, so your x minus 2 is going to be plus 2 to the right, and this is your equation. So here, your range obviously starts from 0, and it will end at infinity. So you know your range is actually any positive number. For the second one, where it's 1 over x, you know your graph is actually like this, and your range is everything but 0 again, because your x-axis is going to turn into an asymptote. So this is the quick recap of what your domains and ranges are. Then, now that you remember what your domains and ranges are, we can move to the second point of our background information. So what is it going to be about? It's going to be about intercepts and intersections. Again, very easy, but it's very important to remember them. So what are intercepts and what are intersections? Well, let's remember the equation of a straight line. If you don't, here it is. It's y equals to mx plus b, where b is called your y-intercept, your m is going to be your slope, and your x's and y, you know what they are. So let us here graph an example of a straight line equation, and let's say we have something like this. Here, this is, let's say, 1, and this is going to be negative 1. What is your equation going to be? You know that your, let's say your y is going to be 0, and your m is unknown, and your x is here 1, and your b is your y-intercept, which is minus 1, so your m is actually 1, and that's your slope. And then, so your equation here is going to be y equals to x minus 1. So now you know what the y-intercept is. This is your y-intercept. It's always the intersection with the y-axis. Whenever the line crosses the y-axis, those are your y-intercepts, and it occurs when your x is equals to 0. So if you replace here x by 0, you're going to get y equals to minus 1. Then you have the second option, the second point is your x-intercept. X-intercept occurs when your y is equals to 0. So here, to get y equals to 0, your x is going to equals to 1. And this 1, 0 is your x-intercept. Third, the third point is the intersection, which is, let's go back to our parabola, which was like, let's just draw it in another color. So this was your parabola, and then you want to know if they ever intersect each other. So you know that here, your first one, your y was equals to x squared over 4, and in the second one, your y is x equal minus 1. So in order to know when do they intersect, you're going to equate them to each other. So you're going to say x squared over 4 equals to x minus 1. And then you're going to have x squared minus 4x plus 1 equals to 0. Is there a number that you multiply to get 1 and add to get minus 4? No. So here, there is no intersection. But in case there was any intersection, your x values are going to reveal it. And that would be our second part. You remember your intercepts, your intersections, and your domain and range. Now we can move to our third part, which is tangents and perpendicular lines. Now, what are tangents and what are perpendicular lines? Well, I always like these with the circles because they're easiest there, but then I'll explain it on curves. Let's say you have a circle, and sorry, it doesn't look like a circle, it's more of an egg, but whatever. if you have here a line that just touches the circle, this is going to be your tangent. Now, if you have a curve instead, so let's say we have our parabola, the x squared over 4. This is our parabola. If there is a line that just touches our parabola, this is going to be our tangent. Now, what is special about the tangent, and this is what is important for this chapter. The thing about tangents is that tangents are straight lines, as you can see. Well, semi-straight in my drawing, but they're actually straight lines. The thing about tangents is that their slope is equal to the slope of the curve at that point. So at that point. So here, as we know, the slope is changing for the curve. It's like this, it's like this, it's like this, and then it keeps changing until it comes here where it's just on the red line, and then it continues changing. So the value at this tiny point over here, let's say at 2, 0, just at x equal 2, then you're going to have the slope of the curve equal exactly to the slope of that tangent. So if they tell you what is special about this line tangent to this curve, at that point you say at that point they have the same gradient. Then our second thing is perpendicular lines. Now, perpendicular lines are almost exactly the opposite. For our awesome parabola here, we said that this is our tangent. Now, what if I instead come and give a line like this here, and I tell you there's a right angle? This basically means that here, what color didn't we use? Black. So here we said our slope is going to be exactly like the red line. Now here, when we draw this slope, it's going to be exactly perpendicular to that line. So what is special about this? Well, the special part is that perpendicular lines have a slope equals to -1 over the slope of the curve at that point. And the way we say it is that m1 into m2 equals to -1, where m is the slope of the line, and m1 is the slope of the line, and m2 is the slope of the curve at that point. So yes, that's what's special about tangent and perpendicular lines. And by that, we're done with our third thing to review. Now, our fourth thing is going to be differentiation. Now, differentiation is a huge chapter, and you've suffered over and over with it in C3. And actually, if you want to review this, you can actually view our C3 tutorials once they're launched on the website. And if you're watching it if you're watching this video when all the videos are already launched, you're lucky. You can just go back and check them. What is important to us, however, for this chapter is only one rule in differentiation. Actually, other rules can come, but let's just cover this one important rule because it comes often. So, our chain rule. Now, I want you to first recall what differentiation is. Differentiation is the rate of change. So, as we give you in the parabola, the slope kept changing. This is because, so there's a rate of change, and the slope is dy by dx. So, it's how much the y changed over a given x. It can change in every unit, or it can be constant for the whole line, just like, for example, a straight line. So, for a line, the slope is dy by dx. Now, what was special about the chain rule, it explains that a very important aspect is that you don't need to have the dy by dx in order to know the slope, but if you have two different values in terms of each other, you can actually still get the slope. So if we have instead dw by dx, but at the same time you know dy by dw, then if you multiply them together, you're going to simply get this and this done together in order to get your dy by dx. And that was all what the chain rule was about, which is in fact beautiful because it's very simple, yet it explains a lot. And that would be the fourth part. which means we can move on to our fifth and final part. What is it? It is called trigonometric identities. Now, for those of you who are done with C3, if you don't do the C34 combined, then you're blessed because you're done with the 300 billion identities you need to know. Why am I doing a cross section? Anyway, let's just remove this. Anyway, so trigonometric identities are a lot, but once you get used to them, they make your life 1,000 times easier because, well, they're just about memorization. And if you have the good enough skills to notice when you need to use them, and this is what this tutorial is about. It's about telling you, yes, you need to know that you need to use them here, and no, you don't need to use them here. So let us start with the basics. If you remember, the main rules were like so, ka, toa, in case you have any triangles to solve with. So you know that here, if you have a triangle with the angle here, that's supposed to be alpha. This is your opposite, this is your hypotenuse, and this is your adjacent. Your sine is opposite over adjacent, your cosine is adjacent over hypotenuse, and your tangent is opposite over adjacent. Now, what are the identities related to your sine, cosine, and tangent? Well, the first and most important rule anyone should remember is cosine squared x plus sine squared x is equal to 1. Then we can move on to more difficult ones. Well, here we go. There is one that said this is the addition one, which is sine A plus B is sine A cosine B plus sine A cosine sine B cosine A. Note that this one is usually given in your booklet actually. And then your cosine A plus B is going to be cosine A cosine A cosine B minus sine A sine B. And then for sine, for the tan, that's it likes to be different from the others, but it is tan A plus tan B over 1 minus tan A tan B. So tan A plus tan B over 1 minus tan A tan B. Then you have the negative, where I'm not going to rewrite them, but we're going to put them red to you so you know the differences. Instead of plus, you're going to have minus here, and for cosine minus, you're going to have, instead of minus, a plus, and for tangent, if this is going to be a minus, you're going to have a negative here and a positive here. It's just switching signs really. And those would be your first 7 identities. Then you're going to move to the other examples, which is what other important ones can you face? There is the double angle formula, which is sine 2a and cosine 2a, where you simply just replace your b's with a's here and you're going to get them. But they're very important because here if you have sine 2a, you're going to have 2 sine a cosine b. And here if you have cosine 2a, you're going to have cosine squared a minus sine squared a. And what's special about this is you can replace here the first identity in order to get, instead of sine squared, it's going to be 1 minus cosine squared. So it's going to be 1 minus 2 cosine squared a. This is the double angle formula. This is the actual identities, and there is also the half angle formula, but it's very unimportant and unnecessary in this chapter. But if you can know it for later on, that would be great. And by the way, for tan, you replace your b with an a, and you're gonna get it, and it's going to be easy. I can't think of any other important identity that you need to know or try to prove. So now we can actually move on. Let me just, okay, then we can now, move on to actually explaining. So now that we're done with the background information, you're supposed to be ready in order to move on to the next part, which is the part about definitions. It's a very short part, so it's going to be combined in a video with the questions. And see you then in that video, and we're done.